Hi, and welcome to this EDR Workbench demo screencast. My name is Andrew Tan. I'm one of the founders of Entrust, and in this screencast I will show you how to configure any ASN.1 based usage data format using the EDR Workbench platform as well as the EDR Workbench graphical user interface. We'll demonstrate this using the Ericsson GGSN R8 format, which is of ASN.1 type. Before we start with the demo, we'd like to discuss some challenges of CSPs, the objectives of this video demonstration, as well as give an insight into what Entrust and EDR Workbench stand for. We know that more than 3/4 of CSP executives who are managing revenue management systems say that the ease of configuration is a true challenge. We know that almost all of them state that operating costs of these systems are way too high, a large part of which is due to configuration challenges. We know that CSPs really want to reduce vendor dependency and the need for platform coding. And we also know that fast time to market requires a complete configurability of platforms, not platform coding for some specific requirements that operators may have. What are the objectives of this video demonstration? We will demonstrate that any format can be configured without the need for coding or platform adapters. We will demonstrate the ease at which formats can be configured. And we will also demonstrate how you, your partner, or Entrust can configure these new formats on EDR Workbench with a lower cost and time to market than you will find anywhere else. What does Entrust stand for? Entrust is a specialist usage data management company, and we do help communication service providers manage the complete life cycle and maximize the business benefits of usage data through their OSS BSS value chain. There is no other company in this market that has taken such a holistic approach to usage data processing when compared to the Entrust flagship product, EDR Workbench. So what does EDR Workbench stand for? EDR Workbench is a specialist platform which is completely focused on generic usage data management. EDR Workbench enables you to create any kind of usage processing logic fast and easy at lower cost and higher performance than ever seen before. It is finally an open approach which aligns with the individual specific requirements of your business, time to market, and cost. EDR Workbench enables you to design any kind of usage data processing logic based on any kind of usage data format simply by configuration. To do so, we provide the EDR Workbench interactive graphical user interface, which we're looking at now. To start off with, on the left-hand side, what we see is the so-called Repository Explorer. The Repository Explorer gives an overview of factories that have been configured and that I have available locally, and factories that have been configured and that are available on connected servers. The servers could either be installed locally, like here on my laptop, which is called the local repository server, or remote servers. There could be any number of servers in your network, depending on how many EDR Workbench servers you have installed. So to start out with, to build a new factory and a completely new configuration, we'll just hit the New Factory button. Being presented with a number of templates, I'll just pick the empty one, and I'll name our factory Ericsson GGSN R8 Browsing, because that's what we're trying to build. I'm then being presented with an empty canvas showing my playing field for designing the processing stream and also the grammar, the Ericsson R8 grammar. For building a browsing and editing factory for just one format, all we need is a file input and a file output and one grammar which defines the structure of the file that we're trying to read and write. So what I'll do is, here in my toolbox I have a number of so-called bots, and I will pick the file input bot because we want to read a file, and I will start double clicking on it, give it a name, and I'll name this file input bot Ericsson R8 in, and it gives me a number of options for configuration. I'll pick that. One of them is grammar, and we'll skip that for now because we haven't defined the grammar which we want to use to actually read an Ericsson R8 file. But I'll go directly to directories and files because this is where we have to tell our system where to read the files from, what to do while we're processing them, what to do with them when we're done, and what happens when there's an error in the file, for example. I have an environment variable configured which points to my input directory, and I'll just use that for now. So I'll just point that to the data in directory, and as a file prefix I'll just enter anything. This is really just necessary for automated processing. So in automated processing, files prefixed with the letters I and N in this case would be automatically processed. So I don't really have to do this for now, but let's just fill this in. Then I'll define the temporary directory. I'll just use the same one and just give the file a different prefix. So this is the prefix the file will get while it's being processed. I'll define the done directory. What happens with the file when it's done processing. I'll give it a suffix in this case, just call it .done. And then what happens in the case of error, I'll just output the file to an error directory, and I'll give it the suffix .error. So I'm done with the configuration of the file input bot for now. You see there's a little red dot with the white cross. That means the configuration is not complete. It's not complete because we haven't defined a grammar which this file input bot can use to actually read and interpret a file. That's something we'll have to do later. But now let's think about how we output the file once we read it. I already said we'll just use an input and an output in our example. And this file output bot here, which I dragged from the toolbar, is supposed to then write the file once we have read it. So I'll just double click on that again. I'll call it Ericsson R8 out. And again, I'll go into the configuration, and here you can also see I could select a grammar which defines the format in which the file is supposed to be written. I haven't defined the grammar yet, so I'll just have to skip that for now. But let's define the directories where the output should be written to. And again, I'll use my EDR Workbench base directory, and I'll want to write the file to the out directory. I'll prefix any output file with out, and as long as it's not completely written, I'll also write it to the out directory, but I'll prefix it with temp out. Okay, so now I have 2 red dots here, which just means that both configurations are not complete. We'll work on that in a few minutes, and I'll connect the two with a link. So this link is where the data travels. So once we read usage data from a file, the usage data is then being passed on through this link onto the output bot. The interesting thing about this link is any usage data or any data that travels on this type of link is something that we can later on interactively view and edit using this EDR Workbench interactive graphical user interface, which is exactly what we're trying to do. So let's give this link a name. We'll name it browsing R8. Okay. So now we've pretty much defined the workflow. It's very simple. Read something and output it again. Trick here is the data that's on the blue line is something that we can view and edit. So that's the first step that we have to do. The next step that we're doing is we'll have to define the Ericsson R8 grammar so that our system can understand how to read Ericsson R8 and how to write Ericsson R8. For this purpose, we have the so-called grammar editor, which I will invoke now. The grammar editor here on this right-hand side shows a number of base types of grammars that we can define. So one of them would be ASN1. Then we have something that we call regular expression grammars, and that would encompass everything like ASCII grammars, binary grammars, and so forth, SOAP grammars, and XML grammars. And basically, all types of usage data formats can be assigned to one of these basic grammar types. So what we want to try to do is we want to create an ASN.1 grammar for the R8 format. So I'll just right click on that, say add new grammar, and I'll give it a name, Ericsson GGSN R8. So I get a new entry here in this tree, and under this leaf here I can add a new file which then will hold the actual ASN.1 grammar. So I'll do that, and I'll name that Ericsson R8.asn. And what I get then is an empty editor window. So this window is supposed to hold the actual ASN.1 grammar. When you're looking at the specification of ASN.1 grammars, you will see that there's the normal ASN.1 notation you can find in there, and all we have to do to find that here is pretty much just copy and paste that from the specification into EDR Workbench. And I have that in my clipboard, so I'll just paste that in here. And as you can see, there's that's the complete Ericsson R8 grammar with syntax highlighting and everything, and that's all I have to do. Nothing else touched here. So pretty much I have to find all the fields that way and so forth, so that's very, very easy. What we have to do next is we have to tell EDR Workbench how to identify records within the structure. We know from the specification that the R8 format has only detail records, so there's no header or trailer record, and the detail records are identified by this block, call event record. So all I have to do within EDR Workbench is define a mapping between the ASN.1 grammar and EDR Workbench. So what I can do here is click on this mappings button, and up comes another window, and here I right click and just say add mapping, and here it's asking for the ASN.1 context name, and I go back and say, well, the context name to my detail record based on ASN1 is first of all the actual ASN.1 grammar name, followed by 2 colons, and then I go back and say that's the actual, or rather this one is the actual detail record name, or the block name upon which I can identify a detail record. I'll name that record detail for internal purposes. The base record name is root. You can actually derive one record type from another, but that's an advanced topic which we'll not go into here, and I will just name that GGSN as an element. So that's the mapping part. Now EDR Workbench understands how to identify the record types from within ASN.1. But ASN.1 also has data types that are not easy to view. So actually any kind of usage data format, as long as it's not just a simple ASCII format, has some sort of encoding in its format for certain fields. So you might run into binary fields where every little bit means something, or binary coded decimal fields, octet strings, and so forth, that require some conversion in order to be readable and easier to work with. To do that, upon reading and writing, so that means translating it into something readable and vice versa, we can define so-called converters. So for this format, we can actually view the converters, and right now there are none defined, and we can start defining them, which is what we will do. So what we'll do is we'll start off with the first one, and the first one we have is how to convert binary code decimal strings into something that's more readable. We have a number of predefined converters which probably work for 90% of all cases. So in this case, we'll pick the bare hex string, which converts it to something hexadecimal. There are cases where the data types are very vendor specific, very proprietary. No standard conversion will work. One good example is that you have a format where there's 8 bits in a byte, and the first 3 bits mean one thing, the fourth bit means another thing, and the last 4 bits mean something else. And that actually needs to be translated into 3 pieces of information, even though it's just all stored in 1 byte character. And to convert that into something really that you can really work with, you can write your own converters using the internal language OpenBSL. That's not part of this exercise now, but will be part of a future demo. So for now, let's fill in the remaining fields that need to get translated so that they it can actually be viewed and edited easier. And we'll just add additional fields here. So I have filled in all the converters that I want to convert for this format, that I want to have in this format for now. We can always go back and add more converters for other data types or modify existing converters, add vendor-specific, very individual converters that we might have just configured ourselves using OpenBSL. But this should do for now. So what have we done? We have created a new ASN.1 grammar, Ericsson GGSN R8, which has pretty much come out of the specification as a copy and paste exercise. We have told EDR Workbench how to identify the detail record type in this format, and we have defined a number of converters so that we can actually read the content of specific fields. So let's save all that for now. Let's go back to the network editor, because what's still missing here is we still have these 2 red dots here. So these 2 bots here, the file input and file output bots, still don't know what grammar they're supposed to read and write respectively. So we have to assign this grammar to these bots. What we have here is the so-called stores, and the stores, in this example, there's a grammar store. It only holds 1 grammar, the Ericsson R8 grammar that we have just defined. In larger examples, this grammar store would hold all the grammars that you have defined to work within one solution. So these could be just 5, 10, 20, 30, 40 different grammars, depending on how many grammars you need to work with. They are all grammars that you have defined are disabled by default, so I have to go in there and into the settings of the grammar store and actually activate the Ericsson GGSN R8 grammar. And once I've done that, I can then go in to the settings of the file input bot, to the configuration, and actually assign the grammar to this input bot. And so I now have the Ericsson GGSN R8 grammar assigned, and I know from the specification it has a block length of 2048 bytes, so 2 kilobytes, and I'll have to put that in there as well. Not all formats have a block length, but this one has, and I'll have to do the same thing on the output. So I'll assign the grammar here, and I'll also assign the block length so that we have the same output as the input. So this pretty much defines everything. We should be finished with our Ericsson R8 browsing and editing factory, and we're ready to test it. So let's save this complete configuration, and to actually test it, we'll have to hand it over to the EDR Workbench server. So because the server is the only piece that can actually execute the configuration. That's a very simple process. To do so, we close the factory. that we have just configured here, this one, and we can just right click on it, and I want to check it into my local EDR Workbench server, which I have running here on my laptop. And so I right click on the factory in my local checkout directory and just say check in factory, and it will ask me which server I want to check this factory into. I have two configured here. One is local, one is remote. You could have any number of servers here that you could check them into. So for example, your staging server, your quality assurance server, and eventually of course your production server, for example. But this browsing factory I just want to use myself, so just using it locally is fine. So I'll select my local EDR Workbench server and hit OK. And as you can see here, the complete configuration is transferred from my local checkout directory to the EDR Workbench server. This is the same whether you have a very small factory or a complete end-to-end mediation scenario. It's really just a few mouse clicks to transfer a complete configuration from one machine to another. So you don't have to worry about how this information is stored, where it's stored, and how it's being transferred. Everything is being taken care of by EDR Workbench. So I'll close this, and now here I see on my local repository server, I see an entry Ericsson GGSN R8 browsing. So if I haven't made a mistake, I should be able to activate that now. I just right click on this, say activate factory, and it works. What happened in the background is the EDR Workbench server has taken the configuration which I've just made, looked inside it, it saw, oh, okay, I have to generate a dynamic parser for the Ericsson R8 format. It's been looking at all the logics, checking if everything's okay. If everything's okay, it brings up the configuration in running mode. So this factory is actually running on my local server now. And what we want to do is we want to interactively view and edit the content of an R8 file, which is the whole purpose of this exercise. So to do this, I can again right click on the running factory, and EDR Workbench comes with a mode that's called Monitor Browsing, which enables you to interactively connect to any running factory and feed information into it and see how it's being processed in a step-by-step fashion. So let's do that. Monitor Browsing, so the GUI connects to the server in the background, and it comes up with a new dialog. Create new batch, but what's more interesting for now is what has opened up in the background. In the background we see a new window called Data Record Browser, and it consists of 4 parts. The first part will show you individual CDRs or usage data records as they flow through the system. The window down here will show you for each individual record, the individual fields of that record, and you can view and edit them later on. Here on the top right, you see the factory that we have just configured. So you see the input bot, the output bot, and it's all grayed out, which means there's no data in the system at the time. And on the lower right, you see the so-called IDF viewer. The IDF viewer gives you a synchronized view of all the grammars that you have configured in your system, and when you're looking at the CDRs, it will show you the way the grammar has been configured, what data types they are, and so forth. So let's go back to the dialog which has opened up here, and which says, okay, so you want to work in interactive mode. Where do you want to stick data into? In our example, we only have one input, so it only presents us with one input here, the Ericsson R8 in, and it asks us to which file we would like to feed into there. And I have one file already here. It's an R8 format, and all I have to do is then hit OK, and the data is sent to the server. The server processes it and sends back a data feed about the processing that it's doing and the contents and everything that goes with it. So what I can do now is I can look at record number 1. And in record number 1, for record number 1 down here, I see the details of record number 1. So I can now actually see the content of record number 1 all the way to the end. And also when I click on a field here, I see the synchronized view of the IDF viewer telling me what field type it is and what other optional fields there might be, which could also be then inserted into the tree here. So for example, I could right click here and no, I can't add another element, so it's a choice. I can only have one of the two, version 4, version 6 address, and so forth. The idea here is it actually shows you everything that's possible and everything that's in the file. You can go in here and say, I want to change the served MC number from ending with 123 to a 456, and when you save that, it'll be output as 456. So this not only gives you an option to actually view the content of such a file, but change the content as well. And in effect, you could manually create synthetic test CDRs if you wanted to. There are other ways to do this as well, but it's beyond the scope of this demo. So I can look at other CDRs in here and browse through all of them basically. Once I'm done with looking at the data, doing my analysis, I could even search for data through the file and so forth. But once I'm done, I pretty much say close the batch, and that'll save all my changes and close the file. And I could then go back and say create a new batch, open another file, look at it, and so forth. Once I'm completely done, I can say stop monitoring, and monitoring mode will stop. The factory will still run in the background, so I can right click on that and stop that as well. And that's the end of the configuration and browsing and editing exercise. So what we've done in a few minutes is created a completely new factory from scratch for an ASN.1 based format, defined a few one mapping and a few converters, and actually went in, looked at the content, edited some of the content, wrote that back out to another file, and we're finished. So what have we achieved in this demonstration? Well, first of all, we've proven how easy it is to configure a new usage data format without any type of platform coding within EDR Workbench. This is not only true for ASN.1 based formats, but for all popular usage data formats that are out there, including, of course, all ASCII based and binary based formats. We've furthermore proven the speed at which format configurations can be executed. As you could tell, this has only taken me a few minutes to go from scratch to a finished viewer and editor for the Ericsson R8 GGSN format. The steps we have taken to get from nothing to the actual viewer and editor was we created a new factory. We have defined a very simple input-output data flow. We have defined the Ericsson GGSN R8 grammar within EDR Workbench. We then checked in and run the factory, and from that point on we could view and edit Ericsson CDRs. So in summary, EDR Workbench enables you to define any kind of usage data processing scenario, not just a viewer and editor, but any kind of processing and business logic that you could possibly imagine. Define any usage data format just through configuration. Interactively view your processing in a step-by-step fashion. Simply transfer configurations from design to production, and subsequently change any configuration anytime. For more information, contact us at sales@entrust.com or visit us at www.entrust.com. Thank you for listening.